Good.
Yeah, I like to share something here about the ancient celebrities, what they were carrying around and why. Because I heard some discussions about it, like the handbags or some other stuff they were wearing.
Yes.
And I found something else here interesting to discuss on the gear of the gods,
What's that?
starting with Saturn. That was my original starting point here, even without the previous presentation. Because if you come in from abroad to the solar system, then of course the first prominent entity there is Saturn. Ignoring the other two gas balls there, which are all significantly large, of course, but those other two weren't visible for the ancient humans on Earth in historic times. They only could see up to Saturn, or in the Greek name of the celebrity god was Kronos, K.
Right.
Visible here in the relief that it was surprisingly difficult to find historic relief images of Saturn. And this one is from Palmyra. And I only found two photos of this. And that is Saturn. It's from the Roman temple in Palmyra, or Roman building there. And there he is shown with his gear, equipment there, which looks a bit like a harvesting sickle, lawnmower sickle. That is typically the representation you see if you look up other photos, reliefs, paintings of Saturn, shown like a Grim Reaper style with a classic farmer sickle then. But here it's different. It doesn't really look like a farming tool. It's not pointing, and if you see this strange curve there, and the whole thing with the parallel features that could be considered to be the disk of Saturn, the ring of Saturn, if they could see it in the past, or maybe it was more electrically active that they could see it from Earth, the ancients. Depending on the orbital orientations of Saturn, it's visually a difference. Yes, shown here in the Hubble Space Telescope photos on the bottom. The upper image is in near infrared from JWST, where the disk or the ring is glowing in near infrared compared to the planetary surface. But it could be that, especially with this special representation here, not looking like a standard sickle, that could be really that they saw this feature on the planet. And especially when comparing it to Jupiter, the next one, or Zeus by the Greeks. He is holding here in his right hand, which looks like maybe a training dumbbell, but with a muscular arm, athletic body. Could be that he was doing daily trainings there. But I think it looks more like an electromagnetic phenomenon, which is actually visible near the planet Jupiter here in this UV light image. It's actually photo there on the right side in UV light, taken by most likely one of the space telescopes. And this dumbbell shape, the two lobes we are seeing here glowing, is actually a ring, a torus seen from the side. But it's only a visual representation of this dumbbell. But it looks similar when interpreting it as a 2D image from Earth. And it's an actually feature, only not, at least today, not visible in visual light, only in ultraviolet light. On the bottom, two other ultraviolet images taken from telescopes or space telescopes. There's also this glow in the orbit of the moon Io, is it? So the endpoints of the the nodules there is the side view of the orbit of the moon Io around Jupiter. And the whole thing is known as the Io-Jupiter plasma torus. There's several megaamps current flowing through it and making the plasma glowing in UV light there. Could be that it was more active in the past. Because I don't think that the ancient observers in Rome had space telescopes or ultraviolet telescopes, so most likely it was more active then. And a more similar, actually three-dimensional object really resembling the dumbbell hold in Zeus or Jupiter's hand here are the two Fermi globes. Fermi bubbles is the name around the Milky Way galaxy. On the right, it's an actual photo, wide-angle photo from the NASA Fermi. That is not X-rays on the bottom in the European A Rosetta space telescopes. It's a larger X-ray bubble. And the smaller on top by NASA Fermi is here in gamma rays, higher frequency X-rays. And that is actually a three-dimensional two-lobe structure, more resembling it. Could also be that something similar was active in the Jupiter Io system in the past. And it scales well here. It's 400 billion times larger than the Jupiter system here. Electric phenomena scale well in space.
Yeah, sure seems to.
We have those lobes on the poles of the sun as well, that we probably can't see right now. Well, we obviously can't see them right now, but they have been able to detect there's polar configurations on the sun. And if you look at the Twin Jet Nebula and the Butterfly Nebula, all these different nebulas, these are stars.
Yeah, the name of the clouds around Eta Carina, yeah, it looks similar. And I also found while researching here a paper about Saturn, where a similar structure was recently seen. I don't remember in which frequency range, but it looks similar in the Saturn system.
Do you have a picture of that?
No, unfortunately, but I can find it later again. While searching for other papers around it, photos, I saw that somewhere.
Sure.
The next one in the sequence is Mars, Ares by the Greeks, or Horus the Red by the ancient Egyptians. And there I could not find a direct correlation about the possible observance. Because Mars is typically represented as looking like a normal Roman soldier or Praetorian Guard here in the image on the right. In his right hand here in the Mars statue on the Nervus Forum in Rome on the left side, he's holding a short staff, but it was actually in the past a long spear, so the classic soldier equipment for Romans at that time, with a shield and the spear. And except for his maybe the socks or shoes are a bit special with a lion face on them. But that's the only special equipment there I could find. Maybe the helmet, but it's a normal soldier helmet. And there is, of course, the large scar on Mars, which might have been visible in the past from Earth, which a bit appears similar to the Eye of Horus. Could be. Some are saying that it looks really similar. The lost eye or the surviving eye of Horus in the ancient mythology. Maybe it was glowing after the event which created the scar on Mars in the past. Could be. But Mars is a bit outside here from the classic statue representations. I could not find a direct correlation to the planets there. And I don't want to go into the phase on Mars story here, which would be, of course, interesting, but not today.
Sure. I think it's easy to believe that the Valles Marineris was glowing in infrared, but wow, if it was glowing visibly, that would have been.
Yeah, if you have a large scarring electric discharge event, and it was glowing for some time in infrared, yeah, correct, infrared more, yeah.
You'd probably still have to have a much closer Mars to be able to
see it.
Yeah.
I agree. Sorry,
But Mars is a bit outside here of this series today, just to not ignore him. Yeah. And the next one, of course, Venus or Aphrodite by the Greeks, with the famous Botticelli Birth of Venus painting from the 15th century. The long golden glowing hair and the seashell. And the seashell, if I look at modern comet photos, looks similar to the double layer, also sometimes called bow shock, in front of the head, in front of the coma towards the sun. That could be interpreted as a seashell shape by the ancient artists who don't know what it is. And the hair, of course, the long hair is the type 2 dust comet tail, dusty plasma comet tail, like visible here in those fantastic comet photos from Gerhard Rehmann, from Comet Leonard on top, from 2021, and the bottom Hale Bob, and the ancient name of comets was sometimes hair star. So that is definitely a correlation. But why? What's the connection with the planet Venus? Well, the planet also has a tail, as it was found for the first time in 1982. The tail of Venus was measured by the Pioneer Venus orbiter, was a mission. In 1982, it was measured relatively near to the planet. They measured the Venus tail there. And then not much happened until 1997, when it was first measured at a larger distance, 45 million kilometers away, near Earth, was the Venus tail measured by sensors on the spacecraft SOHO, which is still active. The LASCO camera on the SOHO is still active for daily solar images. And at that time, the CELIAS instrument with its CTOF sensor was also active. The special ion sensor or particle sensor, which could measure the ions coming through the Venus tail near Earth, near the L1.1 million kilometers away from Earth, 45 million kilometers away from Venus. And that was measured in 1996 during a near inferior conjunction of Venus, where it was only half a degree from the perfect conjunction, from a solar transit. So it was not a solar transit, but it was half a degree away from the solar transit only. And that was the reason the Venus tail was then pointing directly to Earth and could be measured by the SOHO spacecraft directly at that location. And the equipment was, of course, there with the CTOF sensor on SOHO. And SOHO was only launched a few years before, I guess 2 years before. That was a lucky coincidence that they could measure the Venus tail there. And the paper presenting this finding here was from 1997 by Grünwald, Marcia Neugebauer from JPL, also famous, Martin Hilchenbach from Max Planck Institute for Solar System Research is today's name. And back then it was named the Max Planck Institute for Aeronomy. And aeronomy is the research of the ionosphere. Special term used in Germany at least. And they had this CTOF sensor or the CELIAS, and with inside the CELIAS instrument built by DLR and measured the carbon and oxygen ions in the Venus tail, carbon and oxygen ions. That was 1997. And then later, it was never measured again. So that was the only time the Venus tail was actually measured, photographed, or not photographed, but measured. And in this paper, the authors were writing, subsequent analysis is needed, and we plan to release further research in a secondary paper soon, but that never happened. And I asked here Martin Hilchenbach a few months ago, before he died in August, why no other paper was released later, and most likely for a technical reason, because he stated that the safety transistor of the instrument failed shortly after, so they could not reactivate the instrument again. And the whole Soyuz spacecraft faced an almost catastrophic failure in late 1997, I guess, was it? But then they could recover it and activate the Celias again, but the other sensor was never activated again later. And no other spacecraft was tried, or instrument was tried to measure the Venus tail. And the closest current instrument possible, which would be maybe possible to measure it, would be on the ACE satellite. One instrument, I have the name here. On the ACE satellite, the ULEIS, ULEIS instrument, that is also an ion detector that may be able to measure it. But you, of course, need an inferior conjunction of Venus to get the tail near the Earth location, because that ACE spacecraft is also at the L1 point, so similar to Sol. So here was the comet tail of Venus actually measured, as predicted by Velikovsky in 1950s and 1950, and predicted by others, and then observed in 1982 by a Pioneer Venus orbiter mission, and finally measured here. But today it's not directly visible from Earth, but might be with higher electric activity, the solar system in the past might have been visible there. The next one in the series is Mercury, or Hermes by the Greeks. And his equipment is the famous Hermes staff, a straight rod with intertwined helical serpents around it, two serpents, two snakes. Wings on the shoes and on the helmet, but those wings most likely only visualize the speed of Mercury as planet moving around the sun. But the staff is really mysterious, difficult to explain what it could symbolize, what the ancient artist saw there, which made him draw it or construct a statue in this way. Also, interesting smaller detail is that the serpent's radius is increasing with distance from one point. So the radius is increasing here to the end. And there are two serpents. It's not the staff of Aesculape. That is, the staff of Aesculape only has one snake, one serpent. That is usually used by medical doctors, medical community. And then this Hermes staff is wrongly used by a medical organization sometimes because they just confuse it most likely. But that's not the medical staff. That is the rod of Asclepius for the medical community. Here is a Hermes staff or Mercury staff. And how it turned out, the planet Mercury also has a tail similar to Venus. That was completely unexpected, maybe by some. It was first discovered in 2001 only. So similar late to the Venus tail measured near Earth. This one was completely not measured until 2001. It was predicted since 1980s, I guess only. Yeah, it was predicted since only the early 1980s, and then actually observed 2001. And this photo on the right is actually a photo taken on Earth with a small telescope by Sebastian Volkmar. And he made a few fantastic Mercury tail photos in 2022. That is one of those, where the tail is clearly visible there, quite long. And it's a sodium tail here. It's not like Venus currently with carbon and oxygen ions. Here it's neutral sodium. So it's not sodium ions, it's neutral sodium. And of course, to glow, because it's self-luminous, to glow, it needs to be ionized and then falling back to the neutral state to make it glow in the sodium 580 nanometer line. It's a typical sodium yellow glow, also used by old street lamps. Low and high pressure sodium lamps have the same color. And that might also explain why it was not seen before, because especially near telescopes, yeah, I know it from the local San Jose, there's this telescope here on the mountain, and the whole city was converted to sodium lamps in the past to reduce the light contamination for the telescope. They're on the mountain nearby. That's telescope measurements were not affected because they could filter out this specific sodium wavelength then for their observations. But that, of course, prevented, because they filtered out the sodium wavelengths, that would prevent then actually seeing this sodium tail, because it is only glowing in the sodium wavelengths, not in no other wavelengths. That could explain it, why it was never observed before 2001.
This is optical?
That is a normal small telescope. Sebastian Volkmar is an amateur astronomer, so an independent astronomer with a small telescope he has there.
That's amazing.
That
And
is.
I don't know what he especially found out how to capture it multiple times. Maybe some most likely he has some limiting filter reducing the other light around. That is key, most likely, because you really can focus on the 580 nanometer sodium wavelength there. And he saw it in 2022. And also one reason why it is really, it might be difficult to see, because it's only seasonal active. And the activity depends on Mercury's position in its orbit. And it's only active, that is actually sensor observation of Mercury's sodium activity around the planet. And it's more or it's getting active only if the radial velocity towards the sun is high.
Right.
This the direction doesn't matter, just radial velocity component towards the sun needs to be high, because that then shifts due to the optical Doppler shift, the wavelength, the absorption wavelengths of the sodium, that it gets energy from sunlight. Because the sunlight has the largest gap in the sunlight from the Fraunhofer gap lines there is sodium. That means the sunlight is not activating the sodium, because the sodium or the individual neutral atom sodiums, like a gas here, can only receive energy in this wavelength, in the absorption wavelength. And if that matches the dark gap in the sunlight, it doesn't get activated. But if the absorption line shifts due to the sodium movement towards the sun or away from the sun at high enough speed, then there's a mismatch and it gets light received from the sun, and the sodium is activated, ionized, and then glowing. It's the reason for the seasonal activity only. So if photographers then need to match this activity with the vision possibilities from Earth. It's also difficult for Mercury, so close to the sun, of course, and that makes it difficult to see. Here's another photo on the right also from Sebastian Volkmar. It's a multiple exposure, but the size of the Pleiades here is correct. With the same telescope, same hour most likely taken, just to show the size, the angular size comparison of the Mercury tail, which is quite long here compared to the Pleiades on top. And it's like any sodium tail, like any neutral sodium tail, which is also observed at comets, like Hale-Bopp was the first way it was observed as sodium as a third tail of a comet, is completely straight because it's neutral sodium. That means it's not affected by the solar electromagnetic field. And it's straight because those are individual sodium atoms, not and those are really small compared to dust particles in the other tails or other ions in the plasma tails. And that is the explanation that it is not affected by the orbital speed so much because the velocity of the sodium atoms outflowing into the tail away is so high compared to the orbital speed that it is almost straight then, always. It's still a bit mysterious, but with this Doppler effect mismatch, which is even increasing as effect with higher speed, and due to the mismatch, the acceleration force, the solar radiation pressure on the atoms is increasing, and with increasing absorption, the acceleration increases. With acceleration increase, the speed increases, and with higher speeds, the Doppler effect mismatches even or matches even less the absorption spectra with the Fraunhofer gap, and you get higher force and higher acceleration force even more. That's a galloping feedback effect then, and accelerating the sodium to several hundred kilometers per second then, finally.
Wow.
That allows the straight line then. It's still a bit strange how it is collimating that perfectly. So not all is solved there, I guess, about the neutral sodium tails also of comets. And the straightness then is possible represented in the past in mythology with this pair here of Odin or Wotan. Wotan and Odin is the same celebrity in ancient times in Europe. And his spear doesn't have that much spirals around. Maybe here from the ornaments in the middle a bit visible, but usually it's just a straight spear. It's a spear of Gungnir, and that is a self-targeting fire and forgot spear, like all the classic gear, the god said. And Odin and Wotan, that is even by the Romans, they considered that is Mercury, Hermes. That it's the same person in mythology. Also visible in the day name. In French, it is Mercredi, Wednesday. Wednesday in English, Wednesday is Wotan Day. Or that is another hint that it's the same person. And he has a straight spear there without the two intertwined serpents. So that might be just the straight tail of Mercury here then, the spear. And it's always targeting the Mercury, always self-centering by the solar wind. Not by the solar wind, by the solar radiation pressure. It is something different. The solar radiation pressure is considered to be a force effect by light, not by the solar wind so much. So that was now the straight part of the Hermes staff, the Mercury staff. What's about the intertwined serpents? The helix, true helix twins. That could be the gyrating charged particles in the tail, which is observed at comet tails here. In this one from Pons-Brooks. Pons-Brooks is a comet which was also seen with its horns around the head. It's the same, but it also had a helical tail pattern here in the dust tail visible. A single helix here in this case. And this single helix can also be seen in gas discharge tubes here on the right in these experiments here in the presentation or lab. Low pressure gas tubes. The blue one most likely nitrogen. And there the helical glowing discharge is around a magnetic field here. So near the tube a bar magnet is placed that it is then gyrating the charged particles here, the electrons around gyrating in the magnetic field. And at the same time, the gas discharge tube activates the plasma of electricity, high voltage. Then we can see the gyrating, here in this case, electrons in the magnetic field. The glowing is a spiral. But it's only one spiral here, because here it's only as charge carriers, we only see electrons in the tube. And interesting here in this video, here I linked here on the right by Holger from University of Kiel. First you see a straight line of glowing nitrogen, and then he introduces the magnet, and then it starts slowly to twirl around. It's interesting animation visible there. It's moving like a snake around, and slowly, within maybe 1 minute it takes to create this helical pattern. And that is the same physical effect happening in this helical pattern seen in comet tails. And there it's not electrons as charge carriers, there it is charged particles, here larger dust particles or large ions, but here most likely large dust particles or clusters of ions, because those have a much larger gyro radius. The gyro radius is linear depending on the mass of the particle, and the electron is magnitude of 1,000 smaller in mass than the smallest atom like hydrogen, and several tens of thousands magnitude smaller than those particles here in the comet tail. That means those particles have a gyro radius which is then practically in the range of tens of thousands of kilometers or even more if they are larger clusters of particles. That is simple physics here ongoing. And only one spiral, one helix, because here's only one type of charged particles, most likely positive ions in the dust tail. But we need two to explain the Hermes staff with the two intertwined snakes. And to achieve this, we would need a second type of charge carriers in the other polarity. And that, and that we have in comets also, because comets also have negative ions, which found out later here. It's seen at Comet Halley and at Comet 67P. Negative ions were found in the comet tail around the comet. So we have two charge carriers then, which would gyrate, move in two different opposite directions, and then create the two snakes, two serpents around the Hermes star or whatever it was representing, the Mercury tail. And the reason they are focused thin beams of charged particles visible here in this glowing discharge tube is due to the pinch effect of electric current in plasma. So they're not flowing randomly in a cylindric surface, for example, because they are bonding together. Then the currents flowing in the same direction bundle together in the pinch effect and then create a single discharge channel. And if the opposite charge carrier comes in, that would then create a channel in the opposite direction, which is also known here in the twisted filaments of Birkeland currents. Like here shown in the upper left, the blue and red are opposite electric currents or opposite charge carriers. And one would expect that they are repelling each other by the Ampere force law, but they are not, because it's a complicated situation here with many helical movements and feedback effects between the electric and magnetic fields in the Birkeland currents, that actually in the end the currents join together and twist around each other, forming a twin helix, which is visible in space in various clouds here in dust clouds shown here. And on the bottom is an actually photo from the Cygnus loop, the Space Telescope, where the same structures are visible intertwining around itself. Even multiple charge discharges here, more than 2 snakes actually. And to achieve the magnetic field, there's of course no bar magnet in the comet tail here which creates it. We need an electric current. And the electric current was found in comet tails recently, or relatively recently in the 1980s, like demonstrated or shown here in those two papers. In 1987 by James McKenney, or in 1998 by Devan Azoka Mendes. Both show electric current in the comet tail. Here by McKenney, the major feature is the incoming electron beam coming from the sun direction here on the left, flowing into the comet electron beam, but then continuing through the tail away from the sun. And in the other direction, the positive tail ions are incoming then towards the comet in McKenney's model. So here in the tail, we have an electric current, positive going towards the comet, negative electrons going away. That means an electric current in the technical direction coming from the border of the solar system towards the sun direction, towards the comet. And here in Mendes, 1988, in his paper, the electron are coming in the other direction from the tail towards the sun direction, towards the comet in the center. That means the technical current flow would be here away from the comet, away from the sun, into the tail. But both have this focused electric current in the tail. That was surprising. Here marked. And interesting also that Mendes already named it field-aligned electron beam. And field-aligned electron beam or field-aligned magnetic field-aligned current, that is a Birkeland current by definition. But he never explained in his paper, I looked it up in the original 1988 paper, where this drawing is. It was never explained in that paper. So other things in the drawing are explained in the paper. But about the field-aligned electron beam here in the tail, no word was left in the paper. Also in later papers, the figure was repeated by him in 2014 in the other paper, but still no mentioning about the field-aligned electron beam here in the tail. But we have either in this direction, Mechanic's direction, or Mendy's direction. The other one, there is a electric DC current flowing through the tail. And that means around this straight current then is a circular magnetic field shaped like a cylinder. And that would be then a Birkeland current. And that Birkeland current then creates all the patterns we know from Birkeland's currents, like the helical, even twin helical features visible in other locations in space. So that could explain the twin serpent Mercury staff around the straight incoming current there. And the current and the neutral sodium would be matching the name location here. Maybe the current is also activating the neutral sodium then even more, that it glows even brighter. That could explain then, but the situation that the ancient artists really saw something there in the sky. And
Yeah.
with 4 planets now, Saturn, Jupiter, Mars I'm excluding, Venus, and Mercury, so 4 planets with their gear, their tools, finding matching similarities in physical phenomena. That is, I guess, not random coincidence anymore. That's a solar system, or at least it was visible for the ancient observers, that there was electric magnetic activity ongoing there in space.
Absolutely.
That's all I have for today here. And it is also interesting that the Venus tail was never tried to measure again later.
Wow.
And this, I only found this drawing here, this low resolution classic 1980s pixelated graphic from 1997 that was shown in the New Scientist magazine here. I have here the URL. And that New Scientist was referring to the 1997 paper in the same year. And there they had, in this magazine, public magazine, they had this drawing here. Venus caught by the tail.
40.
And Marcia Neugebauer is famous because she worked decades at JPL, also in the plasma field. And Martin Hilchenbach in Germany at the DLR, or at the Max Planck Institute, not DLR, it's the Max Planck Institute for Solar System Research in the ionospheric department there. And then the high voltage, the 30 kilovolt high voltage transistor got tried in the instrument shortly after. So a 30 kilovolt transistor got tried in the spacecraft.
Wow.
So the high voltage safety transistor got damaged. I could not find any report about that yet. I only heard about this detail recently.
I've never heard about that either.
Yeah, yeah. I heard about the complete SOHO failure shortly after in 1998 or around that, where they had to recover the satellite. That was also, I guess, it was unexplained why it happened or what triggered it exactly.
I wonder.
So could be some sudden electric effect there.
You would think. See, I've wondered if these comets are creating these caduceus figures, or at least the spinning, yeah, that one. It would seem to me that there would be double layers associated with that everywhere. And as a spacecraft travels fast enough through those double layers, it would probably cause a problem electrically on board.
Yeah, so this traveling through the double layers is actually measured as an AC current that is measured by satellites. It's a measure a high frequency noise in when they are flying at high speed through the double layers. Of course, they are everywhere. So they are not flying through comet tails. I mean, about normal satellites in the Earth environment.
Right. I remember asking Wal Thornhill about why the Apollo astronauts didn't suffer any type of electrical failure as they approached the moon, and he very wisely described that they were just going slow, and that
Yeah,
the speed, the faster the speed, the less time a craft or a comet or a rock has a chance to discharge and accustomate itself to its local environment. And since the Apollo astronauts were going so slow to the moon, they were able to discharge and just fine. So when they landed on the moon, there wasn't any problem. But yeah, you get comets going that fast.
Also big metal
yeah.
rock traveling as well, so it doesn't
Right.
tend to build up as much of a charge.
Yeah.
Dissipates. It also, the Earth and the Moon together are very much a very similar electrical environment as well, relative to
Apparently, things.
traveling closer or further from the sun. You get a really a high disparity. You get that
Sure.
the flux.
Yeah,
Right.
it's especially with the many private lunar landing missions recently failing, and all of them failed near the last 1 kilometer around the moon, or had hiccups at that location.
True. Yeah, there's speculation that I guess it was the Discovery shuttle when it was coming back through that blew up coming back into the ionosphere. There's some speculation that the plasma tail that the sun might have been a little more active during that time. There could have been some level of discharge through the
Oh,
Yeah, the moon also has a sodium tail, so the same tail as Mercury as the moon.
Hmm.
really?
Yeah, that was also recently found out.
So does that reach far enough that the Earth goes through it when?
Yeah, during a solar eclipse, it would point then, or not at all new moons, but during a solar eclipse, it would point to Earth. Then.
Yeah.
So would we go through we would go through the sodium tail of the moon every month?
Well,
Yeah, no, because it's 5 degrees above the
Yeah.
ecliptic plane.
but like only during an eclipse.
Okay.
But
Yeah, it matches only perfectly during the eclipse. Yeah.
Right. Okay. Yeah, I got it.
that's when the Earth's plasma tail, the opposite, when we have a lunar eclipse, the Earth's plasma tail is perfectly situated towards the moon.
Well, you know what? I just realized this probably explains that anomaly with Foucault pendulums during the eclipse. Did you know that there was
I remember that story from 1999. Yeah.
Yeah, that's when they discovered, I don't remember who it was, but they found that there was an anomaly with Foucault pendulums, but only during the eclipse. Well, if you've got a different charge environment that only happens there, yeah, I could see why that might cause a problem with
Yeah,
the
could be. I guess finally the decision was that it was just an atmospheric effect due to the sudden cooling you have during the eclipse. But it's still not completely solved why the pendulums changed. But of course, the weather, the atmosphere is influenced more by charged particles than by anything else,
I think that's exactly what it is, yes.
And here with the Hermes staff, the detail about the increasing radius. So because if that is a gyro radius, it increases with speed, linear. So if the particles are accelerating along the staff direction, then the gyro radius is increasing.
So it increases as it goes toward his hand.
So you see it here. The snake radius increases towards the other end.
But
They're wider apart from the staff at the end.
the speed would increase the other way. So the radius increases going up, but the speed increases going down.
No, if the speed is increasing towards the top here in the staff, in the statue, if the higher speed is on top, then the larger radius is also on top. That is a direct proportional correlation. Higher speed, larger radius.
Okay. Right. Okay.
So if a particle like the sodium, neutral sodium gets accelerated, like it is happening, and it is not neutral anymore, then it would gyrate. Because currently the visual tail is neutral sodium only. That is the reason it is straight.
Wow. It's hard to wrap my brain around the fact that it was neutral sodium and not an ionized form.
Yeah, that is, and the reason is that it is needed to be neutral. Yeah, for the glowing, because it's only glowing if it's falling back to the neutral state. I guess that is a reaction. Or at least it is only glowing if it changes between neutral and ionized state. I don't remember in which direction. I guess it's when it's getting neutral again that it is emitting, and it's absorbing energy to get ionized and then falling back to the neutral state, and it is glowing yellow. And it's not ionized because the ions are in the plasma tail, and the plasma tail is the blue tail here in Hale-Bopp here on the bottom. That is the top one, the blue one is the plasma tail, and Mercury, sodium ions would be in that tail then. But especially with Hale-Bopp, the neutral sodium tail would be on top because that is the most straight tail of the three. Then the plasma tail is slightly bent, and then the dust tail is bent the most on the bottom.
Wow.
And with Hale-Bopp, it was the first time a sodium tail was observed on a comet. It was also a famous paper in 1995, sodium tail discovered on Hale-Bopp with an image.
So I'm seeing two tails. Where's the third one?
Yeah, it's not visible in most images. I only found one image where you can have or two images of Hale-Bopp where the sodium tail is really visible, and it would be on top here as a straight thin line.
Okay.
And I remember at that time, or shortly after, around 2000, when more images were presented, Hale-Bopp, I remember images showing all three tails there in color in some magazines or so, with a yellow in front and then blue and then white.
Wow. That's beautiful. Holger, this has been amazing. Thank you very much for putting this together.
Yeah.
That was fantastic.
Yeah, also.
While you were talking, I actually did a little search on my phone because I had never heard that Odin was associated with Mercury. I had never heard that before, and sure enough,
I knew it a bit because in Germany it's Mittwoch. That doesn't relate to any god. It was middle of the week, but I guess it was named differently. I remember from years ago or so. And then you have Wotan Day, that is Wednesday. And Mercury Day is Mercredi, French.
Right.
And there are also ancient Roman authors writing that they consider Odin Wotan to be Mercury.
Wow.
And the self-targeting spear, the famous equipment, the Gungnir spear. Also, you see the wings on the helmet, the same. Yeah,
Jeez.
It's maybe just that's a younger version, that's the older version. Yeah.
Right. All right. Well, we're going to call it good for today. I really appreciate you doing this again. And I will, like I said, this has been recorded. This will be out. I've just got to do a little editing on it, and I'll post it out to my social media platforms. So.
Fantastic.
And I will share the PDF, and then everyone can click on the links here, actually.
That would be great. Yeah, please send them to me.
Because here's also a great video from 1986 showing McKinney's electric comet model. It was an experiment, actually, even.
Wow. That looks like you nailed it.
And that finding this 1998 paper, that was surprising, because that is an academic paper here. And Mendes is the most famous plasma comet researcher. He's still active.
I think I might have to get a hold of him.
And I wrote an email to his public email address about the current year, but haven't received a reply yet.
Well, and boy, if you get a reply from him, let me know, because I would love to
Yeah.
talk with him more.
Maybe you can also try to contact him.
I will indeed.
Well,
Absolutely.
it's a simple question. What you have the field-aligned electron beam in the paper, in two papers even. There's another one from 2014 where he used the same image again. What is where it is coming from? At least maybe he changed his opinion about it. What would
Maybe.
be interesting to hear the story where it was originally coming from in this drawing here.
Absolutely.
And in 1986, the ICE, International Comet Explorer satellite, was flying through the tail of comet Giacobini-Zinner. And that probe measured the magnetic field. And the probe went through the tail here, behind the core nucleus. And it was first measuring magnetic fields, let's say, in the upper direction, here if you visualize it in the paper. And then immediately, when it crossed the tail, it changed to the lower direction.
Wow.
In the opposite direction, the magnetic field changed. And that means magnetic field is changing into the opposite direction when flying through a cylindrical object. That was the magnetic current around a straight electric current, and the circular field around the conductor. And that could be the reason he came up with the electron beam then, because that would be the electron beam which created the magnetic field which was observed.
There's also been X-ray observations from the tail, hasn't there?
From the front, yeah, that is always pointed out by McKinney, because McKinney has his special model where the electrons are hitting the comet front, and those fast electrons then produce X-rays when hitting hard surface material on the comet, metals. They produce Bremsstrahlung, X-ray.
Wow.
Hmm.
That's so cool. All right.
Thank you.
We will talk. Yeah, thank you very much for everybody here. So enjoy the rest of your weekend, Holger.
No, I will share the PDF later then on my X account, and my account is here. My contact info, Ario info on X, Twitter, or ario.info, the website. And the website is mostly about current Mars images, but it's the contact address here.
Wonderful. I'll make sure and share that as well.
Well,
Okay.
yeah, thank you all. Thank you.
All right. Thanks, Holger. We'll talk
There's
to
an
you later.
opportunity to show it here, and a good Saturday.
Will do.
Good Saturday, is it?
It is. You take care. We'll see you.
Yeah.
Bye-bye.